All right.
So as I was mentioning, we are going to learn the last type of factoring that we have to in this section. And it's called factor by grouping. So if we look at this here, the first day we worked with things that had three separate terms. Okay, and when they have three separate terms, we learned to take out a greatest common factor first, if you can. That doesn't always happen. And then we did the box and this little table and we tried to factor with that. I didn't really go over these rules, so you can kind of ignore that. Then on Tuesday, we learned how to factor when something had two terms. And the first thing you do in all types of factoring is you try to factor out a common factor. If that, once you do that, or if it doesn't have a common factor, then you check if it's difference of squares. And with difference of squares, we talked about it had to have a minus sign. The variables had to be an even power and the numbers had to be perfect squares, which were on the back of that sheet. If it's not difference of squares, then we talked about, is it sum of two cubes or difference of two cubes? With those, you had to have powers of your variable that were multiples of three. So usually it would just be 3 or 6. And then your numbers had to be perfect cubes, which we have on the back of the sheet that you guys have that you'll use on the quiz. Okay. Then today, what we're going to do is this last column, and this is anytime you have 4 terms, we're going to learn factor by grouping. Now, I don't think I put any on here that you have to factor out a common factor first. So you shouldn't have to worry about this, but we'll be doing factor by grouping today. So just so you kind of know how this chart works. So when you do factor by grouping, all 3 of these things have to be true. So the first thing, anytime you see 4 terms, you're going to think of factor by grouping, okay? And as you get further on in math, some teachers will put things where you have to, you end up grouping these 4 things into groups of 2. Some teachers will make it so you have to figure out which 2 to put together. But the way that I made this up, you always group the first 2 and the second 2 together, okay, all the time. Then, once you do that, you look at the first group and you look at what can I take out of both of these? Like, what's the greatest common factor in both? What goes into both of these? A y, right? There's a y in both of them. So I take that y out and I look at y times what gives me xy, that's x. Then this is a plus sign. And then I look at y times what gives me 2y, and I'd need a 2. Okay. Then there's always a plus sign in between. Okay. I shouldn't say that. There's usually a plus sign here. And then you look at this one and you see what can you take out, okay? What goes into both of these is a 3, okay? And then you're looking at 3 times what gives me 3x, that's x. And 3 times what gives me 6, that's 2. Now, you have done this correctly if these 2 are identical. If they're not, then you didn't do it correctly and you'd have to go back and figure out what you did wrong. Now, when those 2 are identical, what I do is I write that down first, but you only write it down one time. And then your other factor is going to be whatever you took out here. And then this. Sometimes it's a +3 that you took out. Sometimes it's a -3 that you took out. So in this case, we took out a +3. Now, if you were on the test and you wanted to see, is that right? You could FOIL this out, and when you do that, you should get these 4 terms. But this is your answer, as long as neither of those could be factored further. And when you have each of them to just be to a, like that X and Y are to the power of 1, you can't factor it anymore. It's when they're squared or cubed or something like that that you could. Now I'm going to look at these two and these two and see what I can take out. And in this one, they both contain an n, so I can take an n out. And I look at n times what gives me np, that's p. N times what gives me 2n, that's 2. Then you're going to take either a positive number out or a negative number out of there, and we're going to take out a positive 8. So I'm going to go plus 8. Okay, if you were taking out a negative 8, then it would be minus 8. And I look at 8 times what gives me 8p, that's p. And then I would look at 8 times what gives me a positive 16, that's 2. And then as long as these two are the same, which they are, I write that one down first. And then what is left in front, which is the n and the plus 8, goes in the other one. Now, if you guys wrote these two in opposite order, that is absolutely fine. So don't worry about that if you have them. Okay? That is your answer. And if you FOIL this out, you'd get those 4 terms. So now if we look at C, if I look at what do I have to take out, because I'm grouping those two and I'm grouping these two all the time. I look at what do I take out of there? I'm going to take out a B. And I think, what do I need? B times what gives me 3BC? That would be a 3 and a C. And then minus B times what gives me a negative 2B? That's 2. Okay. And then I have to take something out of this. And I have a 15 and a 10. So I'm going to go plus 5. I can take a 5 out of there. I have 5 times what gives me 15C? That's 3C. Minus 5 times what gives me a negative 10. So then I would need a negative 2. 5 times a negative 2 is minus 10. And again, what you're checking is, are these two the same? And if they are, you write that down once. And then what's in front of both the parentheses, which is the B plus 5, is what is the other parenthesis. Okay. So now if we go to this one, I'll show you what happens when you have a negative sign in the third term. It's not a lot harder, but it's a little bit different. Okay. So when you're looking at this, do you guys get, I'd take a 9 out as well as an F out? Okay. So a 9 goes into 9 and 45, and I also have an F in each of those. Okay. So what I would do is go 9F times what gives me 9FG, that's G, minus 9F times what gives me 45F, that's 5. Okay. Now, when you have the negative on your third term, you don't know if you should take out a negative 7 or a positive 7. So what I do is I kind of cheat and I say, I know this has to be G minus 5. If this is G minus 5, this automatically has to be G minus 5. And then I look at, what should I take out? Should I take out a negative 7 or should I take out a positive 7? And wouldn't I need to take out a negative 7? You guys get that? Because negative 7 times G is negative 7G. And negative 7 times a negative 5 is plus 35. So whenever my third term is negative, I kind of cheat and I carry this over here and then I look at what goes in front. I know it's a 7. I just don't know if it's a -7 or a +7. And then what I would do, they both have that G minus 5. And then I put what's in front of each. One is a 9F, the other one's -7. And that is your answer. Now, if we look at this next one here, you're looking at what goes into 9 and 36. Well, 9 goes into both of those. And you have an X to the third and an X to the second. And you can take the smaller of those two out front. Okay, so I'm going to take out an X squared. Okay, then I look at 9X squared times what gives me 9X to the third. That's X. And then 9X squared times what gives me 36X squared. You guys get that that would be 4. Everybody understand that? So again, look how my third term is negative. So what I would do is write down this X plus 4 again. And then I'd figure out what needs to go here. Okay. So what times X is going to give me a -4X? That's a -4. And then I would check, is -4 times 4 -16? And it is. Okay. Now what makes this one different? Okay, first I put down the X plus 4. And when you have a term that just has a single X, you don't have to worry about taking it further and factoring it further. However, if you look at the 9X squared minus 4, when it has an X to the second or above, then you have to think about, can you factor it further? Does anyone recognize this as one of the types of things that we've done? It has 2 terms, okay? If it has 2 terms, it could be difference of squares or sum or difference of cubes. With difference of squares, okay, there's a couple rules that have to be true. It has to be a minus sign, and it is. Your variable has to be to an even power, and it is. And 9 and 4 have to both be perfect squares. And on the back side of your cheat sheet, you guys have the perfect squares, and 9 and 4 are perfect squares. So that means this can be factored further. This one cannot, so I just bring that down. Okay, and now we have 9X squared minus 4. So what would I do there? Like, do you remember this difference of squares? What did we do? What were the 2 signs? Plus and minus. And then do you remember if this was X squared, we put an X here and an X here. And then do you remember we took the square root of 9, and that's what went in front of each of these. And the square root of 9 is 3. And then we took the square root of 4, and that's what went here and here. And the square root of 4 is 2. Now, notice these all have a power of 1. So that means you can't factor it any further. So this is our answer. So if you are taking the quiz on Monday, I put a practice quiz and quiz on the same day. The quiz only has 15 questions. So you should be able to do a practice quiz, make sure you know what you're doing, and take the quiz on the same day. But if you stopped here on the quiz, you would still get some points. You just wouldn't get them all if you missed that step. Okay. So this one, if we look, we can factor these 2 together and these 2 together. Okay. So I have to look at what's the biggest number that goes into 48 and 36. You guys know a big number that goes into both of those? 12. 12 is correct. 2 does, 4 does, 3 does. 6 does not. No, 6 does too. But you want to take the biggest one, okay, and 12 goes in there. So then you look at 12 times what gives you 48. That, oh, and also, can I take a variable out? What variable is in both of these? A C. So then I think 12C times what gives me that? That would be 4G. And then 12 times what gives me 36? That would be a 3. I already have the C, so then I need that F. Now again, because that third thing has a minus, I would take and put 4G plus 3F. Okay, and I have to decide what goes in front here. Okay. So notice I need a negative 4DG. So I have a positive 4 right now. So I know I have to take out a negative 1 because this times 4 has to give me a negative 4. Okay, I already have a G. So what I have to multiply or take out here is I need a D there because this times this has to give you that. Negative D times 4G would give me that. And then you can always check, is negative D times this going to give you a negative 3DF? And it would. Now this one, notice I can start putting together. So I do have these two the same, so I'm going to write that down. And then I put what's in front of that and this in the other one, okay? And then these all have a power of 1. So there's nothing else you can do, and that is your answer. Now, if I go down to this last one here, again, I'm going to factor these two together and these two together, okay? So if I look at this, there's no number that goes into 5 and 2. I have an A in one, but not in the other. I have a B in one, but not in the other. But notice I have X squared in both. So I can take X squared out. And then I would think X squared times what would give me this? Well, I would need a 5 and I would need an 8. Then my sign is plus. I would need a 2. I would need a B, but the X squared I already took out. Okay. Now again, that I know should go over here. If it doesn't work out, by the way, when you did that, like if you took this and put it over here and you didn't get something that worked in both when you multiply it, then you'd have to go back here and make sure this was correct. But what I would do is look now, what times 5a would give me a negative 5a y squared. So I already have the 5, but I don't have the negative. I already have the a. So would you guys get that it would be y squared? So negative y squared times 5a is negative 5a y squared. And then this is plus 2b. Well, a negative times 2 is negative 2. I have my b and I have my y squared. Okay. Now I have that common factor, which is 5a plus 2b. What's left there is x squared. What's left here is y squared. Now, whenever you have two terms that are connected by a negative sign and they're both squared, the only thing you can think of is difference of squares if they're both squared. For the cubes, these would have to be 3 or 6. So when you're thinking, is this difference of squares? You have to have a minus, which we do. Your powers have to be even, which they are. And the numbers in front have to be perfect squares. And there's no number in front, it's a 1. And 1, even though we don't really think of it that way, is a perfect square because 1 squared is 1. So this can be taken further. So what we would do then is we would carry down our 5a plus 2b. And then we'd have to factor this, okay? If it's x squared minus y squared, remember with difference of squares, 1 is plus, 1 is minus. If this is x squared, you'd put an x here and an x here. And notice your y squared is second. So that means you have a y here and a y there. Okay, and then this would be your answer. All my variables are just to the power of 1. So there's nothing I have to worry about. All right, so now what we're going to do is try to put everything together. So they're going to give us a couple problems where we have to decide which way it is. So that's really where this comes in. So if you guys would take out your cheat sheet, if you don't have that out, this is something you have to get good at using. Okay. So I'll give you a second to grab that. So how you know which column to go in is how many terms it has. And what I mean by 2 terms is it would be something like this. There'd be 2 different things connected by a plus or minus. 3 terms would look like this. Okay, 3 different things connected by plus or minus. 4 terms would just be like something like this. That's just completely made up of 4 different things. Okay. If in all of these, you have to see if something can be factored out. But I was telling you guys, I don't think I ever make you factor out a common factor with 4. So you can almost scribble that out and just know you wouldn't have to with 4 terms. Okay. So if it's 2 terms, you have to decide is the difference of squares, which they would be powers of 2 or 4 or 6. And only minus works. Okay. If it's not that, then you check, is it sum or difference of cubes? And in those, you have to have powers of 3 or 6. Okay. And then 3 terms, we're going to do this way, which we learned on Monday. And 4 terms is what we learned today. So let's go here. And it says factor completely. Many of these have more than one type of factor. So what that means is you'll factor it one way and then you'll have to do another way. Okay. So if I look at this first one, this has 2 terms. And when it has 2 terms, the first thing you want to do is check if you can factor greatest common factor out. Is there something that goes into 2 and 250? Does a 2 go into both? So I can factor a 2 out. And then I would think 2 times what gives me 2r cubed? That would be r cubed. And 2 times what gives me 250? That would be 125. Okay. Now on your cheat sheet, one thing you guys might want to write is for difference of squares. If you guys want to write off to the side, you would either have x squared, x to the 4th, or x to the 6th. Okay. For sum of 2 cubes, you'd either have x to the 3rd or x to the 6th. So the only one that can be all of them is if you're x to the 6th. And that's when you would look at your numbers and see, are they squares or are they cubes? Okay. Now this one, notice, is a cube. If it's a cube and notice it's a plus sign, that means we're doing sum of two cubes, which is this rule right here. And then I'll remind you how we did that. So if you remember with sum of cubes, what we did is said, what cubed gives me R cubed? And that is R. And then we called this B and we said, what cubed gives me 125? And notice right here, it tells us, this is on the back side of your cheat sheet, it tells us that 5 cubed is 125. So B is 5. Okay. Now, this is sum of cubes, so we're going to use this rule, which really it starts right here. It's going to be, we have to bring that 2 down, okay? And it's going to be A plus B times A squared minus AB plus B squared. Okay. And then you just take your A and B and substitute it in there. So in for A, I put an R. In for B, I put a 5. A squared would be R squared. A times B, when you multiply 5 and R, you always put the number in front of the variable. So it'd be 5R. And then plus B squared, which is 5 squared. And 5 squared is 25. Now, one thing I can tell you guys, when you do sum or difference of cubes, I don't think there's ever a time you can take it further. So we're done here, okay? And like I said on the quiz, if you got, parts of it right, it's not like we get the whole thing wrong. Okay, now we have 2 terms again. We first check, can we take out a common factor? And we can't. Okay. There's nothing that goes into 109 besides 1. We have to decide, is this difference of squares because it's a minus, or is it difference of cubes? And what I want you to think of with that, this one was x to the 4th, wasn't it? Or m to the 4th. And notice this one can have x to the 4th, but these can't. So that tells you it's difference of squares. Okay. So then to remind you how we did difference of squares, we put 2 parentheses down. And with difference of squares, we did a plus and a minus. And then if you remember, if it was m to the 4th, we put half of the m's here and half of the m's here. So that means we put 2 m's here and 2 m's here. With the 100, deciding what to put here and here, we take the square root of 100. You guys know what the square root of 100 is? 10. So 10 and 10. Another way you could look at it is 10 squared is 100. So if it's 100, you put 10 on both sides. Then for 9, the square root of 9 is 3. So you put 3 and 3. Okay. Now, if you have a square, if you look here, if you have a square, it couldn't be these, but it could be difference of squares again. That's what can kind of make it a little difficult, is if it's squared, you do have to check it's not difference of squares. But for it to be difference of squares, 10 has to be on this perfect square, like in the red, okay? And 3 would have to be here in the red. And they're not perfect squares, so that means you can't take that further. You guys get that? Now we have 2 terms again, and if I look back for 2 terms, I check if there's a greatest common factor first. Okay. Is there something that goes into both of these? What does? 7, right? And could I take an X out front? Yeah. And then I can look at 7x times what gives me 7x squared. And that would be x minus 7x times what gives me 14x. And that is 2. Okay, now I've been telling you as we go through, if you are ever left with just an x, not x squared, not x to the third, there's nothing else you can do with it, so you're done. That is your answer. So in that one, we only took out a common term. This one, would you guys know to do what we learned today? The factor by grouping. And do you remember that? Are we good with factor by grouping? Okay, let's go down to E. So we'll skip this one. This one has 3 terms. And when it has 3 terms, if you look back, you check if you can factor something out, and then you do the box and this. And I kind of spoil it because I put the box and this there when it's a trinomial. Okay. Now, if you guys remember from earlier this week on Monday, what we did here, if that was x squared, we put an x squared here. This is -10, so I'd put that there. Okay. And then if you remember, this -10 went here. And then what number is in front of the x went here. Okay. And then you had to decide what are 2 numbers that you multiply to give you -10. So one's positive, one's negative. And when you add them, it gives you a -3. Yep, -5 and a +2. So -5 times 2 is -10. -5 plus 2 is -3. So in one of these boxes, I'm going to put a -5x. In the other one, I'm going to put a 2x. And then what I'm going to do is go back. If you remember, if this was x squared, we have to think of what times itself gives me x squared, and or what times what gives me x squared, and that's x and x. And then for here, it's what times x gives me this, that's -5. X times what gives me 2x, that's 2. And -5 times 2 is -10. So your answer then would be x minus 5 times x plus 2. And notice both of these are to a power of 1. So there's nothing else you have to do there. They're both to a power of 1. So I think what I'm going to do, you guys, just because this is getting long, is I'm going to do this page tomorrow. Okay. Tomorrow, we're just kind of reviewing everything. There's nothing new that you have to learn. So on the worksheet that I am going to give you, I won't have shown you how to solve yet. So because of this, so keep your notes and we'll finish that one page tomorrow. And on the worksheet, you're going to do 1 through 16 because we didn't learn how to solve like that. It's 1 through 16. When I do it. I'll set it out. And I also put it in storage. So again, you don't have to do 17 through 20, okay? Is up here on the podium.